All right, hello everyone and welcome. So now we are going to look at applications of integrals. Okay, so specifically in this video series, we are going to learn how to find area between two curves using integration. Okay, so this should be relatively an easy concept, relatively an easy application of integrals. Okay, right, let's see. So I'm going to explain this concept to you through few examples. Now the first example here is that find the area A of the region enclosed by the graphs f and g. So that's the idea. Okay, so you want to find the area between f and g. So where should you start? If the graph is not provided, the first thing that you should do is actually to draw a rough sketch of these graphs. Okay, so you don't need to be super accurate, just a rough sketch should be sufficient. Now I'm going to start with gx x square. So let's draw x square. Now hopefully from pre-calculus, calculus 1 classes, hopefully you know how to draw the graphs of quadratic functions. Okay, so I'm not going to spend time on that. Okay, I'm going to take it for granted because our focus here is integration. All right, application. So x square, if you draw x square, well, it's a parabola. It looks like this. Now I'm not the best artist in the world, so bear with me on this. Okay, so these graphs are not going to be pretty and super accurate. So this is x square. Okay, right, now you want to draw fx 2x minus x square. Here's how 2x minus x square looks like. That's how it looks like. So this is 2x minus x square. Now again, all right, so okay, x square was g and 2x minus x square, it was labeled as f. All right, yeah, now what they're asking in the question is actually to find the area between these two functions. That's what they're asking. So about sketching the rough, about sketching these functions, quadratic functions, if you don't know how to sketch them, I would recommend you to go back in your calculus 1 pre-calculus notes and recall how to draw these graphs. An easy thing to do is, you should know the shape of these functions. Quadratic functions look like parabola, so that's a good place to start. And then an easy way to draw graphs is to plug some points, right? Substitute some values for x, mark some points and connect those points. So that's an easy way to draw the graphs as well. Okay, now how do you find this area? Here's the idea. So again, I'm going to draw these graphs. To explain the idea, I'm going to draw these graphs separately. Think about this. So first let's draw 2x minus x square. Now we know the shape, so this is how it's looked like, 2x minus x square. So I'm not going to worry about the entire 2x minus x square function. Like, I'm not going to draw like this function for for quite a few x values. Okay, so see here, I didn't even draw what happens to 2x minus x square on negative axis, because I don't need to. Why? Because you are only finding the area between these 2 points, right? So I don't care about what happens elsewhere. Okay, so I'm just drawing the graph in these two limits, between these two limits. Okay, right, so this is 2x minus x square. Now here's the thing. So think about this. How would you find the area under 2x minus x square? Actually, we learned this when we are learning numerical approximations, like in the previous video series, right? So if you want to find the area under this curve, okay, what do you do? So if this is A, if this is B, so let's say this is A and this is B, okay, you just integrate 2x minus x square from A to B. That will give you the area under this curve, right? Area under 2x minus x square, right? Now let's add x square to this graph. So x square looks like this, right? Now think about this. If I integrate x square from A to B, what do I get? If I integrate x square from A to B, I'm gonna get the area under x square. Okay, area under x square, between x axis and x square. So you're gonna get this area, right? Now think about this. So if you want to find the area in between, what do you need to do? Well, it's a simple geometric problem, right? You just need to subtract these two answers. Think about it, okay? If you integrate 2x minus x square between these two limits, it will give you the area of this entire region, okay? Of this entire region. Now, if you integrate x square from a to b, it's gonna give you the area of this bottom region. So like the region that I colored or highlighted by purple color. Now, if you subtract those two, boom, you're gonna get the area in between these two curves. And that makes sense. I mean, think about this. In the word itself, it says between. So it's kind of like rhymes with the subtraction here, right? So if you subtract these two answers, then you're gonna get the area. You're gonna calculate the area between two curves, okay? So it's like a problem where you have a half a circle, and then inside, let's say you have a square. And then the question asking you to find the area highlighted by these black color. So the area highlighted by the black color. So that's what you need to find. So how do you find that? Well, first what you do is you find the area of the half circle, right? That's the entire region. And then from that you subtract the area of the rectangle, and then the remaining is the area highlighted by black. So same idea, okay? Right, so now let's set up this integral. So you just need to subtract these two. Check this out. So we are almost done here. Right, now since we are integrating from between the same limits and with respect to x, I don't need two integrals here. I can just bring them under one integral. It's 2x minus x square dx. I can write it like that, right? I can combine those two integrals. All right, so now what does this mean? Check this out. 2x minus x square is f, right? That's what we call here. 2x minus x square, and x square is gx. So if you want to find the area between these two curves, all what you need to do is subtract the two functions and integrate. That's the idea, okay? Now when you're subtracting, check this out. We subtracted g from f. Now notice f is the function on top and g is the function on bottom, and that makes sense. If you want to find the area in between, you have to subtract the function on bottom from the function on top, right? So the formula is f is the function on top minus function on bottom. Subtract those two and integrate, and that will give you area. That's the general idea going forward. It kind of changes when we run into difficult problems, but we'll see that in another video. Right, now the final thing we need to learn is, okay, so now to integrate we need to know a and b. What are a and b? So check this out. A and b are the intersection points, okay? That means they are the points that these two curves meet, right? So you want to integrate the difference between these two functions between those limits if you want to find the area. So next thing you want to do is you want to find these intersection points. How do you find the intersection points? Well, here's the idea. Intersection points means the points where these two functions meet, right? Meet means these two functions are equal, right? They cross each other. So you want to find the points where 2x minus x square equal to x square. So the points where these two functions meet. Now you need to solve for x. That's what you need to do. Okay, you make two functions equal to each other and solve for x. So here 2x minus x square takes to the right, it's 2x square. Okay, and I'm going to take 2x to the right, so 2x square minus 2x equal to 0. I'm going to factor 2x, so it's x minus 1 equal to 0. So this means this happens either when x is equal to 0 or x is equal to 1. Okay, so a is 0, that means, and b is 1. So at x is equal to 0, the graphs meet. At x is equal to 1, the graphs meet. We don't need the y values because we are integrating with respect to x. We only need the x range, right? So now to complete the problem, we just need to integrate from 0 to 1. 2x minus x square minus x square. You need to integrate between 0 and 1. Okay, so let's integrate this and finish the problem. So 2x minus x square minus x square, 2x square, right? So if I integrate this, I'm gonna get, let's see, 2x if I integrate it, 2x square over 2. 2x square if I integrate it, 2x cube over 3. And you have to evaluate this at 1 and 0 and subtract. 2 cancels out. So x square minus 2x cube over 3, evaluate it at 1 and 0. So let's substitute 1. So 1 square is 1. 1 minus 2 over 3 minus substitute 1. If you substitute 0, excuse me. So if you substitute 0, everything is going to be 0, because when x is equal to 0, of course x square and x cube are 0. So 1 minus 2 over 3. So this is 1 over 3. Right? 1 over 3 unit squares. You're finding area, right? So the unit should be unit squares. Okay, if it is centimeter square. Likewise, in any unit you have, it's squared, because you're finding the area. So that's the area between these two graphs. So the idea is, the workflow is, try to draw a rough sketch of the graphs. If the graphs are not given to you, then find the intersection points. That should be your next step. Okay, find the intersection points. Okay, if they are not given to you, make the functions equal to each other and find the intersection points, and then integrate the difference of these two functions between those intersection points. That's the idea. Okay, I'm gonna do 2-3 examples in the next video, and after that we can tackle some tough problems. I'll see you in the next one.